For Chapter 4, we're going to start talking about solving systems of linear equations. So we're starting off this first section with solving these systems of linear equations by graphing. So our learning goal is I will write and solve systems of linear equations by graphing. And I will solve real-life problems. So the first thing we need to know is what a system of linear equations is. So here's an example of one. It's where we have two or more linear equations that use the same variables. So like y equals x plus 1 and y equals 2x minus 7. We have two equations and two unknowns. Our unknowns are x and y. So this is what we call a system of linear equations. And what we're going to be doing is looking for solutions. And basically, a solution of a system of linear equations is an xy point that works for both equations. So if you think about it, if we think about this as just a line, and this as another line, the solution of this entire system is going to be where those two lines intersect, which really, if you have that idea, then it's a pretty simple concept to solve by graphing. For example 2, I'm given the two equations, y equals negative 2x plus 2 and y equals 3x minus 3. So I'm going to graph this first one in gray and the second one orange. I don't really need to do different colors, but it's kind of nice to keep track of everything on the page. So this is in slope-intercept form, super easy. Start at 2 and go down 2 over 1. So I'm going to start at 2, go down 2 over 1, down 2 over 1, down 2 over 1. The more accurate my graph is, the better my answer is going to be. So let's try and get a nice, straight, accurate line there. So there's the graph of my first equation. My second equation is going to start at negative 3, and it's going to go up 3 over 1, up 3 over 1. So let's connect those points again, trying to keep it really accurate. And I can see pretty clearly that my two lines cross at the point 1, 0. So the solution for this system of equations is 1, 0, or the only point these two equations have in common is 1, 0. I can check that by putting in 0 for y, 1 for x. So does 0 equal negative 2 plus 2? Yep. And then 0 equals 3 times 1 minus 3. I want to check for both equations. 3 minus 3 is 0. So yep, it works for that equation as well. So the solution for this system of equations is the point 1, 0. Okay, now I want you to try it on your own. I want you to graph this system. Y equals x minus 1, y equals negative x plus 3. So I want you to find the solution to this system of equations. Okay, so here I go. Let's graph the first one pink, second one purple. You do not have to make them different colors. I just like to, so I can keep track of what I'm doing. Let's graph y equals x minus 1. So I start at negative 1. And I have an up 1 over 1, so positive 1 slope. Graph that line. Again, making sure that I'm very, very careful with my graph, because if my graph's not accurate, my answer is not going to be correct. Okay, so there's my first line. My second line has the y-intercept of 3, 1, 2, 3, and a slope of negative 1. So down 1 over 1, down 1 over 1. And I can already see where those intersect. Draw my line, and it looks like my intersection point is at 2, 1. So let's substitute that in just to make sure. If I put in 1 equals 2 minus 1, so I'm substituting into my first equation, I get 1 equals 1. My second equation, I'll get 1 equals negative 2 plus 3, so 1 equals 1. So it works for both equations. My solution is 2, 1. Easy as pie. For our final example, we have a real-life situation where you're going to need to come up with the system of equations first, and then you're going to need to graph it in order to figure out the answer. So we have a kicker on a football team. They score 1 point for making an extra point. So that'd be like after a touchdown, you kick, you get an extra point, that's 1 point. Or you get 3 points for making a field goal. The kicker makes a total of 6 extra points and field goals. So altogether, they made 6 of these kicks, and they scored 12 points. Write and solve a system of equations to find how many of each the kicker made. So first we need to identify our variables. So let x equal the number of extra points. And let y equal the number of field goals made. Not the number of points scored from field goals or extra points, but the number actually made. So first of all, we're told there is a total of 6 extra points and field goals. So the number of extra points plus the number of field goals is 6. And then we also know that the total number of points is 12. So if you get 1 point per field goal, 1 point per extra point would be 1 times x. That's how many points you get from extra points. You get 3 points per field goal. So 3 times the number of field goals tells you how many points you get from field goals. And all together, our points have to add up to 12. So this is our situation here. X plus y equals 6, and then our other equation would be 1x or x plus 3y equals 12. And I need to graph these in order to figure out what our solution is. Now in this case, because this is written in standard form, which is going to be common for a lot of our real world problems, they just make more sense to write them out in standard form. What I'm going to do is I'm just going to use my intercepts. If I put in 0 for y, 0 for x, I get 6 for y. If I put in 0 for y, I get 6 for x. So that tells me that my intercepts are 0, 6, and 6, 0. That's a super easy one to graph. 6, and 1, 2, 3, 4, 5, 6. So that is going to be the line that represents my first equation, kind of. And then my second equation, 1x plus 3y equals 12. When I graph this, if I think about let's put this into slope-intercept form actually, because if I put in 0 for y, I'm going to get 12 for x, and that's going to be way off my graph. So x plus 3y equals 12. Subtract x from each side. I get 3y equals negative x plus 12. Divide everything by 3. Y equals negative 1/3 x plus 4. So I start at 4, 1, 2, 3, 4. And I'm going to go down 1 over 3. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3. So luckily my intersection is on this graph, otherwise I'd have to make a bigger graph. Okay, so there is the graph of my second line. So this line is representing the combinations of points possible. This line is representing the combination of number of kicks possible. And you'll see that they intersect at 1, 2, 3, 1, 2, 3. So at the point 3, 3. So remember, X represents how many extra points made. Y is representing how many field goals were made. So if I think about this, obviously 3 plus 3 is going to give me 6, so it works in my first equation. My second equation, I'm getting 3 points from extra points, and I'm getting 3 times 3, or 9 points from field goals. 3 plus 9 is 12, so that point is going to work. So that tells me I made 3 extra points and I made 3 field goals.